Seventh question. Consider the function f of z is equal to z minus a whole raised to m into g of z, where g of a is not equal to 0 for a fixed a belongs to c. Which one of the following is false? Option A is 0 of order m for f, a is pole of order m for 1 by f. 1 by f has an isolated singularity at a. 1 by f has an essential singularity at a. The concept. That 0 of f of z definition. See, a point z is equal to a is called a 0 of f of z if f of a is equal to 0. Order or multiplicity of a 0 means if f of a is equal to 0, then if f of j is equal to 0, f dash a is equal to f double dash a and so on. F raised to n minus 1 of a means first order differentiation, second order differentiation, n minus 1th order of differentiation is equal to 0, but nth order of differentiation of this function not equal to 0, then z is equal to a is a 0 of order n. Representation z is equal to a, f of z is equal to g of z minus a whole raised to n, g of z, where g of a not equal to 0 and g of z is analytic. Simple 0 means if n is equal to 1, then z is equal to a is a simple 0. Now, relation to poles. If f of z has a 0 of order n at z is equal to a, that means f of z is equal to z minus a whole raised to n is here order is n. Then 1 by f of z, 1 by f of z has a pole of order n at z is equal to a. Now, types of singularities. Singularities are broadly divided into two types: isolated and non-isolated singularities. Isolated and non-isolated singularities. If f of z is analytic in open interval, that means z minus a less than or less than 0, 0 less than z modulus of z minus a less than or, but not at z is equal to a, then z is equal to a is an isolated singularity. These are further classified into three main types. First one, removable singularity. See definition. If limit n tends to limit z tends to a, f of z exists. That means this type. Limit z tends to a, f of z exist and is finite and finite, then the singularity at z is equal to a is removable. In such case, the function can be redefined at z is equal to a to make it analytic. Next, pole. In isolated singularity, second type is pole. Definition, limit z tends to a, f of z is equal to infinity. then z is equal to a is called a pole of f of z if f of z behaves like c divided by z minus a whole raised to n near z is equal to a. Here c is not equal to 0, then z is equal to a is a pole of order n. Z is equal to a is a pole of order n. Third one, essential singularity. Definition: if the singularity at z is equal to a is neither removable singularity nor a pole, it is called an essential singularity. Now, option C, 1 by f is isolated singularity at a. This is true. A is a 0 of order m. Here, m for f. This is true. A is a pole of order m for 1 by f. Yes, this is true. By seeing above concept, these are all true. 1 by f has an essential singularity at a. This is false. They are asking for false statement. Therefore, option D is the right answer for this question. Next, try this question. If f of z is equal to z square plus 1, then the zeros of f of z are 1 minus 1, I minus I, 0 I, minus I, 0. Comment your answer in the comment box. Next, 8th question. Given v is equal to xy, that means z is equal to x plus iy. X plus iy. It can be written as in this form: u of x comma y plus iv of x comma y. Z is equal to, it is written in this form. They are given v of xy. Then analytic function f of z is equal to, this is z. This part is for z. This part for f of z. F of z is equal to this. U of xy plus iv of xy for some constant c is. They are given imaginary part and asking for analytic function f of z. See, by using Milne-Thomson method, we can solve that question. If Milne-Thomson function, if f of z is equal to u plus iv is analytic and u is given, real part is given, then if you differentiate partially with respect to x, this f dash of z is equal to u of x plus partial derivative of u with respect to x, partial derivative of v with respect to x. We know that by using Cauchy-Riemann equations, dou u by dou x is equal to dou v by dou y, dou u by dou y is equal to minus dou v by dou x. Substitute this value and this we get ux minus I uy. Here put x is equal to z, y is equal to 0. In this case, u of x, this is a function of xy. In place of x, put z, and in place of y, put 0. Partial derivative of u with respect to x, z of 0 minus I uy z 0. Now integration of this, we get f of z is equal to integration of pi 1 z0 minus I pi 2 z0 into with respect to z plus c. Now similarly, if v is given, imaginary part is given, in that condition f of z is equal to integration vy z0 plus ivx z0 dz plus c. Now given function v is x raised to 4 minus 6 x square y square plus y raised to 4. Differentiate partially with respect to x. Differentiate v partially with respect to x. We get vx. This is 4x cube minus 12x y square. This is constant. Differentiation of constant is 0. Next, differentiate partially with respect to y. We get minus 12x square y plus 4y cube. Here treat x as constant. We get 0 for that. Now put x is equal to 0 and x is equal to z, y is equal to 0. Substitute all values in this. F of z is equal to vy z0 means here in place of x put z, in place of y put 0. That means whole term y is there, therefore whole term becomes 0. Vy becomes 0. Next, plus I vx z0. Now here 4 I 4 z cube. In place of y, if we put 0, it becomes 0. Therefore I 4 z cube with respect to z plus c. Now integration of x raised to n with respect to x is x raised to n plus 1 divided by n plus 1. Therefore I raised to z raised to 4. This 4 get cancelled. Z raised to 4. This is z raised to I. Z raised to 4 plus c. See where is in option I z raised to 4 plus c. This is the right answer. Next. Ninth question. Let pi from C infinity to C infinity be a fractional or bilinear transformation which has 0, 1 and infinity as fixed point. Then pi takes circle two lines, pi maps the right half plane to the upper half plane, pi is the identity map. Such pi does not exist. See, fixed point. Fixed point means a fixed point of a transformation is a point that is mapped to itself. That means that is f of z is equal to z. F of z is equal to z. If, for example, ax plus b mapped to az plus b mapped to z, or else if w is equal to az plus b, this is bilinear, this is linear, az plus b is equal to cz plus d is equal to z in that manner. F of z is equal to z. Here pi has a fixed points. Here that means pi of z has fixed points 0, 1 and infinity. That means z is equal to 0 pi of 0. That means pi of 0 is equal to 0. Z is equal to 1. Pi of 1 is equal to 1. Z is equal to infinity. That means pi of infinity is equal to infinity. Note. Note. This is important. If a transformation has more than two fixed points, it must be the identity map. It must be the identity map. No need to calculation. I already did some calculation part also. Only using by result, we can solve the question. See, has three fixed points. Therefore, pi is an identity map. This is the answer. Simple question. Next, the value of integration under the curve delta e raised to z dot by z cube dz with respect to z, where delta of t is equal to e raised to it, t lies between closed interval 0 to 5 is, see, result, if z is equal to z naught is a pole of order m of f of z, then residue of f z is equal to z naught at z is equal to z naught for mth order. See, residue of f at z is equal to z naught. This is important formula for to find residue. Very, very important. Residue of f at z is equal to z naught 1 by m minus 1 factorial limit z tends to z naught d raised to m minus 1 divided by dz raised to m minus 1 z minus z naught whole raised to m f of z with respect to z. With respect to z. Now, see here with respect to z. Now, 1 by 2 factorial limit z tends to infinity d square dz square. Now, z minus order 3 is there. Therefore, z minus 0 whole raised to 3 divided by given function e raised to z divided by z cube d with respect to dz. This get cancelled. Now 1 by 2 factorial. This get cancelled. Differentiation of e raised to z with respect to z is e raised to z. Next, with respect to z, differentiate this with respect to z, we get e raised to z only. 1 by 2 factorial limit z tends to 0 e raised to z. E raised to 0 means 1. That means 1 by 2. We know that residue of f at z is equal to z naught is equal to 1 by 2 pi I integration under the curve, closed curve f of z dz. Now, here we get, by using this formula, we get 1 by 2. That means 2 pi I into 1 by 2. That means pi I. Pi I. Where is pi I? This. This is the answer for question 10th. Now, 11th question. This is abstract algebra question. We can solve abstract algebra in next videos. I hope this video is useful for you. If you like the video, hit the like button, subscribe this channel for more videos. If you want to practice more questions, join our Telegram group. Link is in the description. Check it once. Thank you for watching.